Okay, question 3. We've got an angle question. There's a few questions if you watch these videos that you'll see I really enjoy, and actually this is one of them because I think they're. I don't want to sound really sad and say they're fun, but I think there is a bit of enjoyment with these because it's a little bit like problem solving. It's not just a boring old question, and I quite like trying to angle chase. All right, so yeah, don't be scared of these. They're actually quite interesting, and the more you practice, the more satisfaction you get out of it. Okay, so let's just read the question first. AC is tangent to the circle, center O, and point of contact B. So basically, just this is a tangent. Okay, so we can see that, right? It touches one, so I think that's quite obvious. Now, the only thing I'm going to say there is I've written that, and the word tangent appears. So I'll be thinking, well, what's my tangent rule? So when I've got a circle that, sorry, you'll have to imagine that's a circle. I've got a tangent. The tangent meets the radius at 90 degrees. Okay, so right away I see the word tangent, that should jump to my head. Okay, DE is a diameter of the circle, and F is a point in the circumference. Now they've been very helpful there. I don't. They probably didn't have to say that, right? I think that because it's clear on the drawing that DE is in fact a diameter, and point F is on the circumference. Like that's fine. They don't have to write that. But again, they're almost telling you, and please read what they say because sometimes they are saying this for a reason. And here, I think it's to jog your memory that if you remember, if you have a circle, okay, and you've got the diameter, so it has to go through the center to be the diameter, okay. This, for example, is not a diameter; that's a chord, okay. If you've got your diameter, if you take a point on the circumference and then draw a line from that diameter at the end of the diameter, that this angle is always 90, always, always, always. So over here, do the same thing. Yeah, that point is always 90 where it touches the two ends of the diameter. Okay, so they've told us that as well. So right away, I'm thinking, right, that's them. They want us to use these two rules, and then they've just given us two angles, which is fine. You see it on the drawing, and we're going to calculate BDF. Okay, so BDF is up here. BDF. Okay, so right away, I don't need to worry about the text anymore. But I think I've extracted the clues that they were trying to give me, and they will sometimes give you little clues. Sometimes it's just rewriting text, which is nonsense, and then just score it out. But you see the word tangent, you should be thinking, right, what's my tangent rule? Okay, we obviously want to use that. And the diameter, it's like, oh, does that help me? So that's two of the big rules. The other rule that is very important. So the radii in a circle are obviously all the same length. Okay, so if the radii are the same length, if we draw a line between the radii, they become isosceles triangles. Okay, now isosceles triangles are marked with these little lines, which means they're the same length. But I like to think on them as pointing to the angles that are the same. Okay, so I've got this as my isosceles triangle. If you imagine this line here, I think it's kind of pointing to that angle. Yeah, and this line is pointing to that angle. Okay. For circles, basically, it's always the two angles on the circumference, right? They're always the same. Okay, the center one is different, and these two are always the same. Okay, so on this one, these two are the same. But that's something that people struggle to identify. Okay, so spotting tangents is going to give you this one. Spotting diameters is going to give you this rule. Spotting radii is going to give you the isosceles triangles. Okay, so that's the three kind of big rules that I always think about. The simpler rule is just on a straight line, angles add up to 180. Okay, so these two angles would be 180, and on a circle, everything adds up to 360, which is just twice 180, obviously. So all these angles in here are going to add up to 360. Okay. In this question, it looks like you're not going to have it, but don't forget, to be fair, you've got your F angles and your Z angles. So that when you see parallel lines, think of your F angle, which is your corresponding angles, or think of your Z angles, right, which is your alternate angles. So that is the same as that. Okay. In fact, the other one, sorry, vertically opposite, which does come into this sometimes. Okay. So this angle is the same as this angle, and this angle is the same as this angle. Okay. So if they're opposite, they're going to be the same. Okay. So that's the same as that. That's it. So that's all your angle rules, right? So if you want to distill a few weeks of your coursework, that's basically it. Okay. So now let's zoom in and see if we can chase some angles. All right. Zoom. Let's see. Here we go. That's not. That's quite good actually, we'll take that, yeah. Okay, nice one. Right, so like I said, the tangent is 90, isn't it? So I know this angle in here is 90. I'm going to go for a smaller pen because I'm zoomed right in. Okay, but you know what I'll do the 90 degrees in like a different colour just so we can spot them. I'll do them in this red, okay? So I know that this, or pink, that's a 90-degree angle, okay? I also know that this is a 90-degree angle, okay? So right away, I've used the two bits of information that the question said, and now I know I've got these two angles. So you know what? The only rule I didn't actually restate, sorry, which is the easiest rule, and that's why I forgot it. Angles inside a triangle add up to 180. I forgot that rule as well, sorry. So there you go, there's another wee rule that I completely forgot to mention. All right. So with the 64 and the 90, I'd instantly be saying, well, tell you what, this in here is going to be a small pen, 180 minus 90 minus 64. Yeah, so that's just going to be 28 degrees in there. Okay, so it's 22 degrees. 28. That's a man that's had too many coffees today. 26 degrees. Okay, so I know that angle. So right away I'm thinking this is quite good. Okay, I know half of the angle already. So that's cool. Okay, I've got my 77 here, and this is 90. And again, with angle chasing, you need to start with something you know and then work out. So I knew this and this, and I was trying to work out. So from 77 and 90, the next angle, obviously, you're going to work out. It's going to be this one in here, isn't it? So this whole angle needs to be 90. I'm going to have to add on 13. Yeah. So that angle in there is 13. Fantastic. And then I'll be thinking, right, well, how can I chase this angle? Maybe I need to go in here. Can't work that out. Don't know. Oh, well, I'm trying to get to here. So how do I get from here to here? Well, what about if we said, and I'll use the purple for this, this is a radius, isn't it? And this is a radius. So this angle is the same as this angle, okay? And I'll just use purple for this. Okay, so that angle is going to be, sorry, the pens are quite thick because I'm zoomed in so far. That is going to be 13. Yeah, so looks good to me. I think that's it. So we've worked out both ends of the angle, so we just need to add them together. So we're going to do 13 plus the 26, and that's going to give us, I'll just write it in blue just for all the colours, we can give us a 9 and a 3, 39 degrees. All right, I'll just zoom back out again. So yeah, I think it's worth, when you start these questions, just to take a little bit of time and just think to yourself, well, what are my rules? Okay. So tangent rule, the base of a triangle, pardon me, the degree rule, vertically opposite, corresponding, alternate, the 180. The one I forgot was the triangle rule, which is obviously quite important. But yeah, I think when you see that, you can see it looks very complicated, but there's not a lot to it. You find your starting position, which is usually the angles you've been given, and away you go. So just start somewhere and see what you get. There's probably other ways to work that out as well, but I think that's the most straightforward. So unsurprising, you're getting a mark for your 20. Let's see, a mark for 13. Yep, a mark for 26, and then a mark for adding them together. Okay. So again, if you just put something down, if you can just work anything out, you're still going to get a mark or two. So just have a bash and see what you get. Don't be shy of trying the question. Okay. Right, 5 minutes to go. Multiply the brackets out. This comes up all the time, and it's so straightforward. Now, look, the way I like to do it is I like to use my box method. Okay, I know people like FOIL. If you want to use that, that's totally fine. But I like doing it this way. Okay, so I just make a little table up. Okay, so I've got 3 here and 2 here. So what I'm going to end up with is 6 answers: one in here, 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 and here, here, here. Okay, I like it just because it's nice and visual. Okay, so x squared and x is x cubed. Okay, so all I've done there is multiply this and this, this and this, this and this. Same in the next line. The only thing that's tricky here, I suppose, is checking that two negatives make a positive. That's it. Now, because of the way I've written it out, i.e., it's in the nice neat order of indices descending, diagonally, we're going to have matching signs, okay? So when I come to add these together and collect the like terms, these are the terms that add together, and these ones, obviously, that's just on its own. Okay, so you should find that every time if you do the nice descending indices, okay? So that's obviously going to give me x cubed at one end and 8 at the other end, because there's nothing for these two. And then the two terms in the middle, minus 4x squared plus 1x squared, so that's minus 3x squared. And then minus 4x minus 2x is going to give us minus 6x. Okay, let's check the marking scheme. Yep, that looks fine. So marks for that, you're getting, I mean, 3 marks is great for that, okay? I've literally just, I mean, it's so basic, you know, if you're struggling with this, then we've really got a problem, I guess. It's really basic algebra. Um, I mean, the negative here, the two negatives make a positive is one thing. The only other thing I can really think is your indices rules. Some people might think, well, this is 2 possibly, or this is 1, I'm not sure, but you know, your indices, you multiply in terms, you add the indices, so that's just 2 plus 1, which is 3. This is 1 plus 1, which is 2. Okay, that's 2, and then, you know, just nothing, so it's, you know, minus 4x squared, minus 4x squared. I don't think there's much in that at all, but you know, it's very straightforward. So yeah, your 3 marks is brilliant for that. You know, great question. So start to multiply the brackets, and then complete that process. So I suppose you're maybe getting a mark for this first line, then a mark for the second line, if you think on it as starting and completing. And then your final mark is just for actually simplifying it and collecting your like terms to give you this final answer. But 3 marks, fantastic. So already in the paper, you know, I'd be saying that's 3 easy marks. I'd say here people do find this tricky. There's actually a lot of knowledge in there, and sometimes spotting things can be hard and needs practice. So I wouldn't say that was the easiest 3 marks going, but I think you can see that there's not many rules they can throw at you, and just to even know one rule, suddenly you get a mark. Okay, um, we said this was basically the same as having an equal sign, and yeah, there's 2 marks here for just rearranging an equation, and then it was a mark for knowing, well, I need to change the direction of my inequality because I'm dividing by a negative. So still 2 marks for just basic algebra. Okay, and the fractions, we've been doing fractions since first year. You know, really not a lot in that. Um, Finding a common denominator. You know, that's it. Find a common denominator is the answer to most fractions questions. Okay, so we should be off to a good start. All right, no one should be thinking, oh, this is tricky. Okay, so yeah, hope that was helpful.